Hello everybody! Today we're going to learn how to divide radicals and rationalize denominators. So I might make this video in two parts just so it's a little shorter and easier to download for you. This whole idea is based on the fact that the square root of a over the square root of b can be written as the square root of a over b. Okay, we know that b can't be 0 in this case. A and b are real numbers. And this particular property we use both directions. In other words, we can use it to break one big fraction into two, the numerator and denominator, or we can use it to take the numerator and denominator and write it as one fraction. The reason we might want to do that is to simplify it. Okay, so the goal here is to simplify the expression. Okay, so that means no perfect squares under the square root, right? And it means all the fractions in the problem are reduced, are simplified. Okay, so that's our goal. So let's do number 1 here. So you'll see the square root of 48 over 16. So we can leave it this way, or we can divide it into two pieces and simplify the pieces. So let's do it both ways, okay? So method 1 would be to simplify first. Okay, so we do 48 over 16. And we know that 16 goes into 48 3 times. So that's equal to the square root of 3, right? Pretty simple. Or method 2 would be to break it up into two pieces, the square root of 48 over the square root of 16. Now in this case, we know the square root of 16 is 4, so it's 4 in the denominator. The square root of 48 is 16 times 3, which is the square root of 16 times the square root of 3 all over 4, which is 4 root 3 over 4. And then, because 4 over 4 is 1, we get the square root of 3. So you can see that in this particular case, method 1 was way easier. Sometimes method 2 is easier. It depends on the problem. So it's good to take a look at the problem and decide how you want to do it before you just start. Number 2, the square root of 90 over the square root of 5. So let's do this one in both ways also. Method 1 or method 2. Method 1, I can write it all as one fraction, 90 over 5, right? And then that would be equal to 18. But we got to keep the square root. Don't let the square root fall off, which is the square root of 9 times the square root of 2, which is 3 root 2. Okay, so that's method 1. Put it under one radical sign. Method 2, leave it how it is, or I should say not leave it how it is, because sometimes it's written like this, but rather put it in two radicals. So in this case, this is 9 times 10. 9's a perfect square, so we want that there. The square root of 5 we can't simplify. So here we have 3 root 10 over root 5. And we get to that point and we notice if I put these under one radical, I can simplify it. So therefore this is not in simplified form. This is 3 root 10 over 5, which is 3 root 2. Okay? So again we see that the first method was quite a bit simpler. You choose. Okay? Number 3. So we'll go with the first method, which is putting both numbers under the same radical. So it would be 160 over 5. So the 12 over 2 is 6. We've got to reduce that, right? And then we have the square root. 5 goes into 32 times, I believe. So we get 6 times. Now we have to simplify this. 16 goes into 32 twice. So that gives us 6 root 4. I'm sorry. 6. Let me fix that. I don't need the square root symbol over the 4, right? The square root of 16 is 4. So 6 times 4 root 2, which is 24 root 2. Okay? If we go with the other method, we have 12 over 2 again. We're going to leave this as 160 times 5 over the square root of 5, sorry. So we get 6, and 160, we know that has a perfect square of 16 in it. So 16 times 10 over root 5. So we've got our 6 here. This simplifies to 4 root 10 over root 5. So here we've got, I'm going to put the 6 in the, it's 6 times 4, right? Because they're both essentially in the numerator. And here, again, we can see this simplifies. So in order to simplify it, I need to write it under one radical. So we get 24 root 2, because 10 divided by 5 is 2. Okay, those answers match. So that's how you simplify radicals that have division in them. I'm going to do the second part of this, rationalizing the denominator, in a separate video. So please watch part 2 of this when you're done. Thanks.